Okay, let's dive right in. Just adjust the volume here. Here we go. Okay, we're working on the Last Crusade episode 2. Last week I was working on episode 1, which was pretty easy to solve. Not much in terms of algorithm complexity. Uh, but I take it was just a setup for what we're about to do here in episode 2. Okay, so what will I learn? Backtracking and pathfinding, which involves um, data structures, right? I'm guessing. In this puzzle, you have to use an associative array that maps arbitrary types to directions, which we have done last week, so we'll probably be able to reuse that code. You compute the list of all possible actions from a complex environment, lots of different variables. You go through the nodes of a tree, okay, there you go, using a depth-first search algorithm, which um, I've I had to implement in another puzzle a week or two ago. I think it was the Terminator one. What's called the Skynet something. So might be able to dig into that code and extract some stuff that we can reuse. And it might be a good idea to maybe make some sort of a generic node class, because I have a feeling I'm gonna end up having to implement a lot of trees and graphs uh, as I'm going through all these coding game puzzles. So we'll see about that maybe. Okay, trees to store the list of possibilities over the time. You have to optimize your algorithm to reduce the number of combinations in order to decrease the overall computation time. You have to prune a decision tree based on heuristics, which is, from what I remember, what backtracking is about, right? As you're going down the tree, if you suddenly realize, based on a heuristic function, that you know what, it's not worth going further down that path. It's clearly this isn't where we're going to find the answer we're looking for, right? Well, then you just stop and go back up. Now, how to implement that? It's been a while. I'm gonna have to look into it. You can perform advanced backtracking operations, right? Okay. To help you get started, focus on the puzzle The Last Crusade. Oh, I guess somebody wrote some sort of a blog article about it. Should have taken a look at that beforehand. External resources, those are just Wikipedia articles about all these different data structures. Pretty up to date on these things, so it should be fine. Statement. The goal of the puzzle is to select rooms to pivot from a two-dimensional grid to help Indiana Jones find his way to the exit. This puzzle requires to build a tree of all the possible rotations that can be performed over time and use some heuristics to perform some predictive optimizations to avoid unnecessary computation. Oh, okay. Yeah, that's not going to be trivial. I don't think so. Um, just a quick recap, I guess, here on the story. Indiana Jones never listens. We told him that forbidden temples are dangerous, but there he is, dashing through a moving labyrinth and risking his life. Oh, okay. See how okay. I get it. Dodge the traps and help him find his way out of this highway to hell. Beware of the rolling stone. Oh, oh wow. Okay, yeah. You see it here? There's a rolling stone. Oh, which is probably just some sort of way of forcing us to make the not just wander through the maze aimlessly, right? It's kind of forcing us to find a solution in a certain amount of time, I guess, or move. Yeah, we'll see about that. Now, from what I understand, and I may be wrong, but from what I understand, and from my knowledge of the episode one, Indiana Jones is just following through that tunnel system always going down. He can go down, left, and right. So he's basically being pulled by gravity, as you can see there on screen. And in the previous episode, all you had to set up was basically just some kind of a algorithm to predict which room he would end up in next. So basically, just knowing the rules of the maze, right, of the system was what they got us to do. Now this time around, it looks like they're getting us to manipulate the maze, actually rotate each tile. Well, maybe not each, but I mean, we have to choose which tiles to rotate and in which way. Um, in order for Indiana Jones to get to the exit as fast as possible, avoiding traps and stuff like that. That's not going to be easy because, okay, let's think about this quickly. How would we go about that, right? I think the first thing would be to try to find a path through the maze. If there is one, great. Let's just do that, right? Um, but if there isn't, then we need to change something in the maze and see if we can now find a path, right? That wouldn't be very efficient though. That's where, you know, stations and stuff are going to be, I think, a big part of this puzzle solving thing. Unless, let's see, let's think about this here. Yeah, we're going to need some kind of heuristic to... Oh, this isn't going to be an easy one. Okay, well, let's look at the... Okay, let's look at the... Let's go in. Let's get in there and see if we can get more information about the inputs we're going to get and all that stuff. Okay, so your objective is to write a program capable of predicting the route Indy will take on his way down a tunnel. And that we've kind of, that's what we did last time, all right? Well, actually, no. We weren't predicting the route. We were just asked to give what room he was going to end up in the next turn. But anyways, okay, so the structure of the tunnel hasn't changed. To review the types of the rooms, click here, which probably takes us to... Oh, can't I do... I don't want to... Please open a new tab. Oh, okay, it just opens up to... Cool. So we had implemented all of that last time. However, hold on. Yeah, just okay. However, at the beginning, there is no longer an unbroken safe route from start to finish. Okay, there you go. So we know there is no route at the very beginning. Fortunately, certain rooms can now be rotated each turn by a quarter turn clockwise or counterclockwise. Oh, that's even more complications. Wow, okay. Some rooms are locked in place and cannot be rotated. These rooms have a negative type in the provided grid. A negative type. What? So maybe like type -1? Is that what they mean? Would be a room of type 1, but that can't be rotated? Okay. Furthermore, you cannot rotate the rooms containing Indy or leading to the exit. All right. This turnaround, your mission consists of writing a program capable of rotating tunnel rooms in order to lead Indy to safety. Yeah. Lastly, for the last two tests only, giant rocks can appear within the tunnel system. If Indy comes into contact with a rock, he dies. The rocks have the following behavior. They can arrive on any game turn. They only arrive from an edge of the grid Okay. They follow the same rules of movement as Indy and disappear if they leave the grid. If a rock hits a wall or gets stuck, it will be destroyed and disappear from the grid on the next turn. You cannot rotate a room containing a rock. You do not need to anticipate the arrival of rocks in your algorithm. Whatever choices you made before a rock appears, if you had a chance to win before the arrival, you will still have a chance after the arrival of the rock. Okay. All right. On each game term, you are given Indy's current position. That was the case in the previous episode. Then you can spin a room clockwise or counterclockwise with the commands left and right. Oh, so only one room, right? Is that part of the... certain rooms can now be rotated each turn by a quarter turn clockwise or counterclockwise. Some rooms, I don't know. It doesn't say here, but it seems to imply that we can only rotate one room at a time with the commands left and right, or do nothing with the command wait. Indy will then have advanced to the next room according to the shape of the current room. Victory conditions. Indy reaches the exit. Lose conditions. Indy slams into a wall while exiting a room. Interrupted route. You have failed. Indy finds himself in the same room as the rock on the same turn. You have failed. Or Indy stops moving. You have failed. Okay. The tests provided are similar to the validation tests used to compute the final score, but remain different. Yeah. And it kind of sucks that we don't actually get to see the test cases. But I guess maybe that's to avoid people just hard coding solutions. I don't know. Okay, so the program must first read the initialization. That's pretty much the same thing as last time, I think. Although we're now, okay, that's during the game loop. Okay. Input one game turn. X, Y, Y, Y equals I. So that's the same thing. Two integers to indicate Indy's current position on the grid. Pause I is a single word indicating Indy's entrance point into the current room. I think that's what we had last time too. Top, left, right. Next line, R, an integer representing the number of rocks currently on the grid. That is new. We didn't have that last time. And next R lines is each line represents the position of a rock on the grid. Oh, there can be more than one rock at a single. Oof. That's interesting. Output for one game turn. This is what we need to give the coding games engine. X and Y left, X and Y right, or wait. So rotate the room at XY by a quarter turn counterclockwise or, okay, I get it. What are our constraints? So yeah, it does seem like we can only rotate one room at a time. Okay, here's an example. Here's an example. That's our initialization input. So it means we have a tunnel system of 2 rooms width, 4 rooms depth, which is what we're seeing here. Boop, 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 boop. These are the room types. So room 4, room -3. Okay, there it goes. That's our answer. So it means a room of type 3, but it's locked. You can't rotate it. Okay. Yeah, this is going to be a complex one, I think. Grid with 2 columns, 4 lines, 2 rooms are locked. That's right. Which ones are locked? These 2 here. -3, -10. No output expected. Input for turn 1, 1, 0. So ND is at index 1, 0, which is here. 1R. What is that? Oh, that's a rock. Yeah. So there's one rock. And the rock is at 0, 2. So 0, 2. That's what we're seeing here. It's pretty small, but okay. So now what do we do? Rotate the room 0, 1 to the right to create a route to exit. So 0, 1 would be this one here. Rotate it to the right would make a link between these two. So that's what we're doing. And now we're getting back our input, and these now at 1, 1. The rock has, moved to 1, 2. So now we say, well, oh, don't move anything. We've got a path now. So wait. Indy moves again. And so on. Now the room exits. The rock exits. No longer a threat. Indy just slides down. Things are getting tough. The tunnel is in fact filled with booby traps, and it's up to you and your newfound ancient tunnel expertise to get Indy out of this bind. Yeah, that's not going to be an easy one, and the interesting thing is that there is a part 3. There's an episode 3, so I don't know what they're going to throw at us in there, but let's worry about this one first. Okay, so here's what we're going to do. We're just going to take this here. Copy it into our main right here. Can get rid of that. Just need to tell TypeScript about declare function readline returns a string. There you go. TypeScript won't complain about this function it doesn't know about. Readline, as I've said numerous times on this channel, is a built-in function into coding games engine. So that's why TypeScript doesn't know about it. Okay. And now let's just sync our external IDE with this project here. I'm doing Last Crusade 2. Okay. There we go. Upload from local file. And we're synced. Good. So now, so now whenever I make changes in here, it will be synced into the coding game IDE. Now if we just run the first test case and see what happens. Nice. I want to see this though. I was like super, oh yeah, basically just, that's cool. Oh, okay, we just dropped, I have a feeling this is just a simple like, boop, one way down, and it's just to get us to rotate this one here, and we're done. So it's just an easy one to start with. Still, it's going to be interesting to try to solve this. All right, let's just quickly take a look at what we did in Last Crusade 1. All right, to predict Indy position. So that's what we needed to do. So that was our main algorithm we implemented. We've got the room types here, so that can probably be reused. I'll just copy this into the this one here. Okay. And predict Indy position. Are we gonna need this? We probably will, because we need, that's gonna be part of our algorithm at least. I also have a, okay, so let's bring that in here. Let's bring that in here. Now if we just look at our main, I think what was I doing? Add line to grid. Yeah, that's basically our setup here. Okay, there's the grid. I'm storing the grid here. This is just a function to push information to the grid. Blah, 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 blah. Okay. So I think we can reuse that stuff. But this time we're just gonna, okay, let's close this. Don't think we're going to be needing this anymore. This is probably going to be called something else. Oh, array 2D. Yeah, definitely going to need that. So let's bring that in. I have a problem where with rollup, if I try to, let's say from in here, so from the Last Crusade 2 file, if I try to go and import, well, actually, let's do it. You guys will see what I mean. So if I go, and then one more level up, and now I go into my, helpers folder, and then in the helpers folder, I go into source, and then array 2D, right? So TypeScript's like, yeah, okay, fine. I see it, works, good, whatever. But then, when I, okay, but I gotta hook this up. So just to give you, okay, hold on. If I were to shove that in here, because right now predict and depause is not hooked up to our main function, but let's say I was going to be doing that here and actually using it, so const whatever foo is equal to array 2D, oops, array 2D. Now, there you go. See what it does? Roll ups blowing up. I'm getting the stupid error. Unexpected token. Note that you need plugins to import files that are not JavaScript. I know that, and I am using a plugin, a TypeScript plugin, and it works fine. It works fine until I try to import a file that is higher than the root directory for my current project, right? So anytime I try to import a TypeScript file that is higher than, I think, no, not even source, just outside of this folder, outside of Last Crusade 2, then it's acting stupid. Like, so it's not like it's obviously finding the file. Look, this is the content of the file, right? That's the content of the file, but it's saying, oh, it's not JavaScript. Yeah, I know. What's wrong with you? Why do you expect JavaScript all of a sudden? I've got the plugin in there. So if any of you know what's going on, let me know in the comments, in the chat, or even if you're seeing this video afterwards on YouTube or whatever, put it in the comments, because it's likely that I won't have figured it out yet, and that would be helpful. But so in the meantime, I'm just stuck taking my helper functions and just copying them into each puzzle, because I don't want to take hours and hours to try to figure out what's going on. All right, so let's just undo what I just did. Get rid of that, and we're good. See, compiling file now. Compiling fine, I mean. Okay, so let's bring in our array 2D. Oops. Come on. Okay. In here, I guess. And now we can just do this. Should work. All right. Okay. Now we'll just change the name of this, because oh, well, actually, no, that's not true. We're probably going to be keeping this. So, okay. First thing we're going to do is populate our tunnel system. Let's hook up our grid. Let's see the main function here. What are we passing? What are we passing add line to grid? We're passing a string. And we're pushing the line, we're splitting it, and okay. So then our grid just ends up being a string of the room type. So that's a start. Let's do that. Each line represents a line in the grid and contains W integers t. The absolute value of t uh, of of t specifies the type of the room. If t is negative, the room cannot be rotated. Gotcha. Information that is important. Are we going to deal with that right now? Not yet. We're just content to let's try to hook this up. So, what did I call this? Add line, is it? Or add line to grid, aptly named. That is exactly what we want to do. So let's do that. Add. What happened to our comment here? Interesting. Okay. Add line to grid. And we're just going to pass in the line. And yeah, we're going to care about that. But for now, let's just log this out to make sure we've got a correct representation of our grid. And grid. Can we import that from? I think I made it an export. Yep. So, okay, so let's run this, see what happens. All right, so it looks like we do have a correct representation. So zeros are just blocked, as you can see here, just like solid earth. Nothing you can do with that. So 0, 0, -3, 2, -3. So let's take a look. -3, meaning we can't move it, but this is the type, so it just goes straight down. So we know that our exit is probably here, and we know that this is the start point. We will anyways, once we start. And 2, as we can clearly see, we start like this, and then boom, no worky. So we need to rotate this. Simple enough for this one. So there's 2 things I'm going to have to do I can think of right now. The one thing I need to do first is add a type. Okay. Add a room type. I don't think I had implemented room 0. I had not. So we're going to do that. Room 0. Now, if we're coming in from the left, we can't go anywhere. We can't go anywhere. We can't go anywhere. How am I going to represent that? I don't know yet. Let's just make these null for now. So no matter where you're coming from, you end up dead. Now TypeScript's saying, hey, dude, that is not. Null is not a proper type of room. Right, type room is, you expect a directions. So these things, yeah, okay, room is basically a syntax string, this, okay, so either a function like that, or, no, there we go. No, it's happy. Yeah. Okay, so that's done. Now, let's take a look at this thing. It predicts Indy's position. Room cannot invoke an object which is possibly null. Ugh. Ugh. Yeah. Okay, I don't want to have to. So instead, how about this? Give it the position and you return. Okay, so either return a string or return null. And then we're gonna have a basically a direction. No, that's not gonna work. Yeah. We'll just make it a direction, and the direction will be called dead. How's that? So I need to keep the same signature, basically. Boom. Then you return. Should I make it a string that says dead, or should I just make it null? I think I should just make it null. For now, anyways. And so now you can just say directions.dead. Which makes no sense, but whatever. Might tweak that later on. Well, I could have made it directions.hell. That's where you're headed to. Or cemetery. Or crematorium. Or, you know, bug food. It's getting dark. Okay. Okay. So this works out. And what are you complaining about? Type string, no, it's not assignable type string. Oh yeah, because I'm supposed to return a string. Ugh. Well, yeah, you're gonna return a string and no, that's what you're gonna do. Okay. Yeah, we'll probably change that behavior later though, but we'll see. Okay, so I got that hooked up. I do need to know about the exit at some point. Where am I going to store that? We'll see. Let's see now. We've got, what's this here? This is, right, Indy's position, and that's where he was coming from. So the room he's currently in, how he entered the room. Why is that? Yeah, okay. And this is for rocks. We don't care about rocks for now. Write an action using console log. So, okay, so really, the only thing we need to do for this simple one, because we know now, having looked at the maze, is to turn one, rotate that thing, and then just wait. And that should work. So let's just make sure that we know we're dealing with the syntax properly. So we're looking at room 0, 1, 2, 1. So actually the Y is first. So 1, 2. No, that's not right. 0, 1, 2, 0, 1. Yeah, okay, I guess it's right. So we're looking at room 1, 2. And then we rotate that to the, well, it doesn't make a difference in this case, but we'll say right. So it should be 1, 2, right. I think that's all. And then, okay, let's just try that, see what happens. Now, failure. Indy crashed on a wall and died. You rotated cell 1, 2 to the right. Indy tried to move from cell 2, 0 to cell 2, 1, entering from the top. And it didn't work? Why? Oh, 2, 1. Oh, we have to wait a second. So the X comes first. Okay. The X comes first. Try again. I lost. Invalid instruction. You cannot rotate cell 2, 1 as Indy is currently in it. And he tried to move from cell 2, 1 to cell 2, 2, entering from the top, but I guess our invalid instruction kind of screwed things up. So I would have to do, this is totally not how we're going to be doing this, but just for the sake of getting that first test case done, let's do this. Let turn count. Let turn count. Count equals 0. And then this might actually come in handy later on. We'll see for optimizations and stuff. But so once you've done that, then you go turn count plus plus, and then I'm just gonna go if turn count is equal to 0. Otherwise, yeah, we'll do it that way. So if turn count's equal to 0, do this. Otherwise, just wait. And that should do it. That should do it. Our super algorithm to fix this problem is done. Boom. But I think this is gonna not work for the next one. Okay, so we actually get to kind of see. Let's put that full screen. Oh, that's much better because now we see. We have a much better understanding of what was going on. Boom, rotate it, and we win. Cool. Cool. Okay. Replay and share. Nice. Broken sewer. Let's try that. Let's put full screen though. Maybe we'll get a better understanding of the maze. Alright, so right away we can tell that we need to rotate this counterclockwise, right? So that goes like this, and then this one's going to need to be rotated whatever, and then he keeps going. So on and so forth. Okay. So for now, I don't think okay, let's just start by taking a look at the maze here, which is what we have. So we know just from looking that he starts in here, -3. It goes here. Now, where's the exit, though? How do we know which one's the exit? This is probably the exit because the exit is always blocked. You can't have it, not blocked, but I mean locked. You can't rotate it, so it would be this one just by looking. But if we wanted to store that somewhere, we could. They're sending that information to us. Okay, so basically I think what we need to do is something like woo, all the way over there, boom, then get down here, and then boo, boom. Right? It's pretty much our only option. All these are blocked. So that's what we need to do. Go here, rotate whatever we need to rotate, and get down and rotate whatever we need to rotate, and we're done. So how do we go though? Like as an algorithm, how do we go about doing that? There's two things I can think of. We know the exit. We know the starting point. We could make well, in this particular case, so maybe let's just keep it simple. In this particular case, there really isn't any pathfinding to do. We just need to guide Indy, and I don't mean really guide, but I just all we need to do is make sure Indy can keep going on its current path. There's no decisions to be made. There's no options, right? He can't go left or right or up or down at any point. The only option he has here is to go right or die. So it's a simple matter of rotating this. And then he keeps going. We just make sure that he can keep going. And then once it gets there, yeah, so maybe for now, the algorithm should simply be look at where Indy's supposed to go, then look at from there where he would exit, and if that's if he dies, then we need to rotate that. hmm Just like a one look ahead kind of thing. That's all we need here. And that would also solve our previous test case. So let's implement that, and we'll get more complicated if we need to as we go through the test cases. So what do we need? We need to, oh, well, there you go, predict Indy position. That's exactly what we want. That's exactly what we want. Okay. So, how do we hook that up though? We hook it up in here in the game loop. Let us just get rid of this. We could always keep the turn count in there. I don't need this. Oh, that's a good reminder though, so, but I don't need this. Okay, so first thing, predict where Indy's going to be. So predict Indy position, and we feed Indy's current position, which is yi, all caps apparently, yi, xi, and the entry, which is pos I. And that should output in string format, I think. No, maybe. Let return room entry. Okay, we need to look at this. Okay, this is the format. We're basically getting the X, a space, and the Y in string format. So that's cool. Yep, that's good. We can use that. Okay. So now that we have that, now what? Now we need to do the same thing on this new position. And right, so we need to do, okay, so this will be Indy's next pause. Oh, we also need to keep track of where he's coming from, not just not just um, huh. Hmm. Because right now, all we're doing is saying, all right, he's in this room, position Y, position X, and he's going down, or he entered this room here, going down. Well, then he's going to end up into room position this. That's great. We get to know where he's going to be next. But if we want to do the same thing on the next room, right now we're being given the position he's entering from by the engine. But if we want to look ahead, we need to figure out for the next room the position he's coming from. How are we going to do this? So it's not hooked up for that right now. I mean, I could, yep. I'm just going to have to hard code it in here. That's the only thing I can think of. Maybe add it at the end. That way it would use the exact same. Oh yeah, but then it's kind of annoying. It means I need to, okay, let's make this into an object then. We might as well. It'll be easier to access. Instead of a string, we'll make it into an object. And the object will be simply of type X, number, Y, number, and entry, string, right? Something like that. So that's basically what we're feeding to this thing. And that's exactly what we're feeding to this thing. So let's do that. Should I make this into another type? Probably. We could probably call this what are we gonna call this? Entry indie pause is what we're gonna call this. Just do that like this, good. And now we're going to return indie pause here or null. And now this is going crazy because this isn't right. Okay, so we just change this here to. I'm not going to make this a class. It's just holding data. Although at some point maybe, I don't know, we'll see. So our X, actually that's quite simple, right? Boom. X is X, Y is Y, and then the complicated part. Why isn't this working? Left side of comma operator is unused and has no side effects. Oh, it's not. Right, it's not seeing this as an object because it's just seeing that as a statement. If I do it that way though, would that work? Yeah, it's saying you're returning an object of X, Y. Of course, this is saying, yeah, it's not right because we're missing the entry info. Let's hard code it to a string and then, oh, I would have thought that down would have, oh, like this. Y. Maybe all of them have to be right. Yeah, it's highlighting the whole thing because, okay, once I'll be done implementing this for all of them. But actually now what I need to do is y is equal to y plus 1. Okay. Okay, so we might as well do this correctly. Oh. Are we going to be able to do this correctly? Ah, crap. No. Right, because the entry will be dependent on where they're coming from, and we don't have that information. Oh, wait, do we? If I'm at this position, then depending on the type, I end up at this position, and I'm coming from oh yeah, it's always the opposite, right? If I'm currently going down, so this is how it works, right? If I'm going down, I'm saying, okay, then if I'm going left, then okay, then you need to go down for the next one. So the entry would be the opposite of that. So it would simply be top. I think that would work. Okay, we're fine. We're fine. Do not panic yet. Okay, and this, need a comma here. What are we doing here? We're doing x needs to be x minus 1, and y stays the same, so I can just use the shorthand here. An entry would be right? If you're going left, you're coming in from the right. Okay, and then the opposite here. X plus 1. Entry is from the left. If you're going right, then it means you're coming in from the left. Okay. And dead, well, we're okay to just have null. Is that right? Did we do this right? X stays the same, y plus 1. X minus 1, y stays the same. X plus 1, y stays the same. We're good. I think we can delete this here. Like that. And see, TypeScript loves us now. Alright. Okay. We're good with this. Now this is freaking out. Because, why is it freaking out? We're predicting in these position. We're passing in that stuff. It's doing its thing. And then it's saying in type any pause null is not assignable to type string null. Right. This is now outputting a indie pause. Indie pause. And since you need to know about this, I need to export this type and import in here. And now everyone's happy. And now this is what I'm getting here. An object of type indie pause or null if we end up in a wall or something. So now this is Indy's next position. We take Indy's next position and we go Indy's next pause dot y. Oops. Okay, so Indy's next pause dot y. Indy's next pause dot x. And Indy's next pause dot entry. Right? Indy's next. Why? What's the matter? What's the matter? Object is possibly null. Oh yeah. Yeah. If Indy's next boss. But put that into curly braces. Okay. No. Okay. So now we've got something else that we're going to call, I don't know, Indy's next pause. Let's call it two over. I don't know. Look ahead. Yeah, two. Look ahead. Oh, we'll just call it look ahead. Look ahead. Not to be confused with look ahead. And what do I do with that now? Oh. Now I need to check if it's null. If it's null, it means we're ending up in a wait. No, we need to evaluate the type that we get there. That's what we need to do. Wait. Something's not right. That's too simple. Too simple. Let's look at this. So I'm being given Indy's position. If we take this here and as an example, this is our first entry point. So that's Indy's position. So I'm going to be getting like, 0, 1, and so it's going to be like 1, 0. So I'm going to be given 1, 0 top. That's the first input I'm going to be getting. Now if I follow my algorithm so far, I'm going to be looking at the next one, which would give me this here, or type 12. I'm going to be getting the position, right? I'm going to be getting this position here. So that's what I'm returning. I'm returning a position which will be x is still 1, so this will be a 1, 1. And top will be the entry. So cool. So what I need to do is check, well, is that valid? Like, can I even come in from the top? Right? And I can't. I can't with type 12. Do I have a built-in way to check this without having to? And I do. I do. So see, if I get type 12, the only way I can come in is through the right. So if I try to do here, if I try to do mm, if I try to just, let's forget about this for now then. Well, actually, I still have to do that, yeah. So if I try to do room types, where am I using this? Room types.get plus room type. If there's no room, throw new error, invalid room, return room entry plus one. Okay, so using predict indie pause will actually throw an error at some point. Here, yeah, this is where it's gonna screw up. It's going to go undefined, or let's see. I've got a room, that's good, cool. Now I'm trying to access a parameter from the room that doesn't exist. What's the behavior with that again? What does JavaScript do when that happens? Quick check. Using from the console. Refuse to execute inline. I don't care. Okay. Const a equals an object. And now if I try to do a, not foo. It just returns undefined. Okay. Interesting. So it's not throwing or anything. I don't think we want it to either. But now we're going to get nulls. We're going to get undefineds. This is getting confusing. Oh, maybe not. Okay, so in these next pause could actually be undefined. Am I getting this right? I believe I am. Because if this is what I'm returning here, so you could actually return undefined. Which really, that's interesting. Okay, hold on. Room types is a map that returns an object of type room. And the object of type room is index string. Yeah, and then returns this. Now, Okay, is there a way to guard against this? Or do we even want to? How do we use this? All right, well, I think it's a good thing that we're being explicit about the fact that we can get an undefined from this function. We can get a null if In which case would we get a null? We would get a null if we're trying to go into a huh. I don't, yeah, that's not right. I don't even think we need that here because you can't get into 0. You shouldn't even get into 0. So get rid of that. Well, not yet. Let's just think this through for a second. If I'm trying to get into a room type 0, I really can't be getting it. Well, okay, but how do I know that? So, oh yeah, we're going to keep it like that. It's the only thing I can think of for now. So any pause, null, and undefined are all possibilities. Null is like a dude, there is a room, but you can't get out of it, basically, or really technically you can't get into it, but okay, I'm getting confused now. Let's do this one step at a time. Where are we at? We're looking ahead. This is our next, Indy's next pause. Now we're going to be, so it's not null, cool, because it's not a 0. But we're going to be trying to look ahead again. And this is where we should be getting a undefined here. Because we're going to be trying to get entry. So let's go back to taking a look at our maze here. We're going to be getting into the 12, so that's cool. 12 is our Indy's next pause. The thing is we're going to be calling look ahead with Indy's next pause, this information here, but top, and there will be no top position entry in there. So we should return undefined. We are going to be getting undefined in lieu of our look ahead. So look ahead will have the value undefined. Okay. So now what do we do with that information? If look ahead is not is either null or undefined, then we want to rotate that thing, right? We want to rotate that thing. How do we know what? Oh, wow, this is complicated. How do we know whether to rotate it left or rotate it right? Now that means I need to kind of know that these two can be rotated. Actually, not only these two, all these four are rotations of each other. These four are rotation of each other. These two are rotations of each other, and these two are rotations of each other. Oh, how do I use that information? Well, let's just not take that into consideration for now and just simply do a, if this isn't right, then console.log, we need to move that thing. So let's use indies. We're going to be, okay, so we're going to be doing indies next pause dot x. Oh, I need these to be a string, don't I? Although console.log should turn to, oh yeah, but it needs to be formatted properly. So, dollar sign this and that, and then we, oh, template string literal, like that. Okay. Then we need a space. Then we need our y, and these next pause dot y. And then we need to tell it that we want to rotate. Let's make it right. See how far we can get with that. Now, if there is no problem, we just wait, right? If indies next pause, and there's no problem with the look ahead, then we just wait. Or actually, we can just go and put the wait here. Console dot log and wait. Let's see how far we can get with that. We've somehow managed to break the first one. What did we try to do here? Oh, your program did not provide an input in due time. What? 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 Am I missing something here? Okay, this is happening. So if indeed next pause, yeah, but we still have, like, how is it not providing an input? What are we getting here? Standard error stream. Oh, is it because maybe I am... What if I was to just, let's see, get rid of this? No, that shouldn't be the problem because it wasn't a problem before. Oh, type error. Grid.get is not a function. Line answer.js on line 224. What are you talking about? Hmm. Predict indies position. Grid.get. This is the only place where we're actually calling this. And it's saying that it's not a function. And what the heck is answer.js? Probably some internal thing to... Let's take a look here. Oh, or maybe... Oh, okay. Answer.js is like the file that they're compiling to. Okay. So room type equals grid.get. And grid.get is not a function. Why wouldn't it be? What's the grid? The grid is my array 2D. New array 2D. Push seems to be working. Array 2D. Prototype. Dot get. What are you going on about? All right, time for some console debugging. So you're saying that it's not a function. The only place we're trying to call it is here. So let's do console log, or error, grid. Give me grid. Can I take a look at grid? Let's see what grid looks like. Oh yeah, obviously. I'm getting, yeah, okay. That was dumb. Let's see. How would I... Grid.get. How do I know? I'm getting it from here. Just making sure that I get indices. Dot get. Is it not extending array 2D properly? I've used this before with Coding Game. It should be working. Or have I used this with Coding Game before? I have used it, but I haven't used these. Oh. What are you doing to me? I have a feeling. Okay. I have a feeling that somehow grid is just, it's not being recognized as a array 2D, but just as an array. How would we, okay. Here's what we're going to do. Grid, so that would be, how does this work in grid instance of array 2D? And it'll return either true or false, I think. So let's take a look at that. It returns false. Let's look at our code here. Array 2D. It's a class. It extends something. Blah, 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 blah. This is obviously something wrong. I'm doing, well, no. How? I even have tests for that thing. And they all work fine. All right. I do. I do, I do, I do, I do. So what the heck is your problem? And okay, so if I do, let's get back in here. If I do console log error and do grid instance of array, that'll return true. True. Where did I put the other one? The other log. Oh, here. What if I wanted to do it in here? Should be the same thing, but and I get false. So it's saying grid is just an array. It's not an array 2D. Why is it saying that? I'm clearly creating an array 2D here. It's not giving me a hard time here because I'm using an array. Now the answer should be in what it's compiling it to. But this is always a little bit hard to, and it's using an extend function array 2D. Blah blah blah. Return super apply. Ugh. I mean, it's adding it to the prototype. How is that not even? Okay, here's an interesting exercise. Let's take a look at our prototype. Prototype. Why won't you let me? Of course it exists. See, even TypeScript's saying, yo, dude, this is clearly an array 2D. Oh no, it's true. I can't access it from there. I should be doing it from... hold on, how do I... prototype, the object is property of the object constructor and is also at the end. Yeah, that's not what I want. Well, I guess that would be a start if I do array 2D, not prototype. Curious what I'm going to get if I do that. Yeah, right. I'm getting all of my functions and stuff. And and then grid, but when I do new array 2D, where exactly in the code am I doing this? Yeah, new array 2D. So let's see, what is being called when I'm doing new array 2D? This is the array 2D here. The whole extend thing that I'm not clear on. Not quite sure what's going on in here. Yeah, I just figured it out. I just figured it out, I think. Let's try this differently a little bit. Array dot from to be an array. And now why wouldn't you get what? Huh. Interesting. Oh, array 2D, sorry. There we go. Oh, now what? Oh, okay. Gotcha. Can I do string? Maybe like that? Yeah, everybody's happy? So I wonder if that's gonna make a difference in how array 2D dot from was called with an invalid parameter. Parameter was BF type array. It needs to be an array of an array. Oh, well, let me help you with that, friend. Okay. We're still getting the same stupid problem. So that's not the solution. This is annoying. Truly is. Now I'm wondering if it's something to do with... Hey, hold on a second. If I'm doing this... Why am I not... Am I not setting this up for... ES6. No, this shouldn't be a problem. What if I was to do ES7? say yes. Let's just go yes next. Boom. See what's gonna happen. I'm curious. Because I think I had determined before that code in game was using I don't know if it was doing anything with JavaScript. Can't remember. Alright, so let's run this and see what happens. Yeah, I know I lose. Yeah, you don't get the grid. How is that being outputted here though? I mean, why is it doing all this fancy schmancy stuff here? JavaScript has the extend, like why isn't it just extending it? Let's take a look here. TypeScript playground. This is slightly annoying. Can I set? I thought I could set the ES6 ES version. So that's actually okay. That's actually my string extends the string. That's something I was trying to do before, I guess. Saved it. Classic JavaScript works using classes. It's doing the stuff here instead of actually using a JavaScript class. Does it ever though? Like if you I mean, it should technically, right? Let's see. If I was going to actually, let's do this. Let's just really, let's run TSC on that stuff. See what we get. Cannot find name console. Do you need to change the target library? Try changing lib compiler to include DOM. What? Not the DOM, but there's node in there? I mean, console is a node. That is weird. Oh, maybe I just need to add the node types. Do I have them in here? I don't. Oh, and I wasn't even running TSC on the right thing. Stupid me. So let's go to Last Crusade 2. Now if I try to run TSC in here. So that worked. Okay. What did we get? That's what I would love to know. This is the kind of output we're getting. Object, define property, exports. Okay, that's just the export thing. That's cool. But in terms of our class, you can clearly see that it's just using JavaScript class and extend. So why on earth is rollup not doing that? Sometimes, man, the tooling drives me crazy. Why can't I just code? If I look at what it's doing, it's clearly not using ES6, right? It's using vars and stuff. What the heck, man? Come on. And I did set the target to, if I try ES6, ES6, it's got everything we need in there. Oh, that's what I had before though, I think. Wasn't it? Oh, wait a sec. 1029. If I just do... Okay. Now let's take a look at what it did. Yeah, no, it's still using ES5. Ah. That is... I'm this close. I am this close to just switch to Webpack. This is annoying. That and the thing where I can't import from, like, how do I need to set something in Rollup itself to, I mean, it should just take a look at my TS config and figure out what the heck I want. All right, so let's do quick search. Rollup, TypeScript, target. Plugin, seamless integration between Rollup and TypeScript. Yeah, seamless my R's. Ha! Okay. No, okay. No, see. The plugin loads any compilation. Compiler options from the tsconfig JSON file by default. Which one, though? Okay, unless it's... The only thing I can see, then, is that it's loading it maybe from... No, I've got ES next here. What if I was to put this to ES6 just for... I don't know if that's going to change anything, but it might be looking up to the... But no, that wouldn't make sense. That would not make sense, would it? Okay, we compile. Take a look at this thing here. Still using ES6. ES5, I mean. All of this is using vars and alright, so maybe I can try to overwrite this thing and do this. Right in the TypeScript thing. I just want the ES6. And I want ES6. Yes, please. And here too, just for good measure. Okay, I think it recompiled. Let's take a look. Still using vars. Yeah, there's something I'm not getting here. Is it even updating? Am I looking at the right folder? What's going on? Predict NB, that's where I'm doing my console error. Yeah, see, array 2D prototype. It is. If I'm, it's updating. If I'm changing it to just let's say array 2D, boom, recompiles. If I look at the file now, it changed it. Annoying, really annoying. This is like, why? What is going on? I've got it in here. Don't you love it when stuff doesn't make sense? Options dot include the following options are unique to rollup plugin TypeScript. Options include and options dot exclude each a mini-match pattern which determine which files are transpiled by TypeScript. tsconfig when set to false ignores any options specified in the config file. If set to a string that corresponds to a file, TypeScript overrides TypeScript user for transpilation. This should just be working out of the box. All right. Well, you know what? You know what? I'm annoyed enough that I'm going to switch to Webpack. Haven't used it in a while. But at this point, or maybe I could just try using, let's try, I haven't tried this in a, I think TypeScript itself has like some sort of a concatenate kind of thing. I don't think it works really well, but I'd be curious to see how that works. Let's see, let's get rid of these. Let's get rid of these here. Let's do that in one go. Boom, boom, boom. That. Let's clean up our dist. Yep. And I'll just keep that for posterity. Now I need, let's see. Output, out file, out dir. Out dir is going to be dist. And composite true. Enable project compilation. What does that mean? TypeScript composite. Is that it? Composite. Project references. Project references are a new feature in TypeScript 3.0. That's why I didn't know about it. That allow you to structure your TypeScript programs into smaller pieces. By doing this, you can greatly improve build times, enforce logical separation between components, and organize your code in a new and better way. We're also introducing a new mode for TSC, the build flag, that works hand in hand with project references to enable faster TypeScript build. Let's bring that here. It's all new to me. Let's look at a fairly normal program to see how project references can help us better organize it. Imagine you have a project with 2 modules, converter and units. So far so good. And a corresponding test file. Test file imports the implementation files and do some testing. Previously the structure was rather awkward to work with if you used a single tsconfig file. It was possible for the implementation files to import the test files. It wasn't possible to build, test, and src at the same time without having src appear in the output folder name, which you probably don't want. I don't think that's composite. I don't think that's... Don't really think that's what we're looking for. Unless I make it a 2-step thing. I first compile my TypeScript to JavaScript myself, and then just use rollup to bundle the whole JavaScript. All of the JavaScript. That would be an option. Ugh, what a pain. What a pain. It would allow me to remove this here, though. I think this is going to require a bit more research. So that's not very interesting. All right? I love being stuck like that. Let's see here. Yeah, I think I'm going to take this offline because this is some boring stuff. And I'm going to need to read up on it a little bit. I don't know what's going on. Rollup is not bundling my stuff properly. Anyways, not the way I'm expecting it. I'm using what they have in their documentation here. So I don't know what's going on. But I'm going to have to figure it out. Might as well do it now, so I don't have that problem in the future. Alright guys, so I guess that's it for me for today. I will try to fix this so that tomorrow morning we can just focus on coding the actual solution to the problem, the puzzle we're working on. In the meantime, take care.